Welcome to Grandpa's Late Nights. Come in, come in. Settle yourself down wherever you are. Pull the blanket up a little higher if the night's gone cool, and let your shoulders drop away from your ears the way they always forget to. There's no hurry here. There never is on this porch. The light's on, the chair's warm, and we've got all the time in the world tonight. More time than you'd think, as it turns out. That's the funny part. That's the whole reason I wanted to talk to you tonight. Let me tell you a little story before we get into anything heavy, just a small one. Picture an ordinary street, somewhere ordinary, on an ordinary afternoon. Nothing special about it at all. Two people are walking down a sidewalk, going opposite directions, the way people do 1,000 times a day without ever noticing. Maybe one's heading home with a bag of groceries, maybe the other's just out for a stroll, no place in particular to be. And for one single moment, they pass each other. They're side by side, one step apart, close enough that if either of them sneezed, the other one would say, "Bless you." Just two strangers sharing a patch of pavement for half a second. Now here's the strange thing, the thing I can hardly believe myself, even after all these years of turning it over. While those two people are passing each other, one small step apart, breathing the same air on the same sidewalk in the same little slice of an afternoon, they do not agree about what is happening right now in the rest of the universe. Not in some vague, poetic, everybody's got their own truth kind of way. I mean it precisely. I mean it the way an engineer means a measurement, far, far away from that sidewalk, across an almost unimaginable gulf of empty space in another galaxy entirely, a galaxy called Andromeda that sits about 2.5 million light-years from where those two strangers are walking. Imagine something is happening. Let's make it dramatic, just for the picture. Let's say there's a fleet, an alien fleet, sitting in orbit somewhere out there in Andromeda, getting ready to launch on some long voyage. And for one of those two people on the sidewalk, the one walking, say, toward Andromeda, if only by a hair, that fleet has not yet set off. The decision to launch hasn't even been made. It's still sitting in the future, unwritten, waiting to happen. But for the other person, the one walking the other way, away from Andromeda, one single step apart from the first, for that person, the fleet already launched. The decision was made days ago. It's done. It's history. Same sidewalk, same afternoon. One step between them. And they're two versions of what is happening now, 2.5 million light-years away, are separated by days. And here is the part I want you to hold on to as you drift off tonight, the part that's going to take us the whole evening to unwind slowly and gently and all the way to the bottom. Neither of them is wrong. There's no referee we can call in to say which one of them has it right. The universe itself does not have an answer. There is no master clock ticking away somewhere in the back room of reality, keeping the official time for everybody. Their disagreement isn't a mistake. It's not an illusion. It's not bad measurement. It is simply how time works once you look closely enough. And almost nobody ever looks closely enough because in everyday life, it never, ever matters. That's what we're going to do tonight. We're going to look closely, slowly. So slowly you might fall asleep before we reach the end, and if you do, that's perfectly all right. That's exactly what this porch is for. I'm not going anywhere, and neither are these ideas. They'll be right here waiting for you the next time you can't sleep. Truth is, I hope I don't make this so interesting it keeps you awake. But if I do, well, at least you'll have learned something strange and beautiful before sunrise. A fair trade, I'd say. So get comfortable. Find the cool side of the pillow if you haven't already. We're going to take this in the smallest possible steps, one little idea at a time. And I promise you don't have to understand every single piece for it to do its quiet work on you. You can let half of it wash right over you like the sound of rain on a roof. The shape of the thing will still get through. That's all that matters tonight. And before we go any further into the dark, let me just say we If you find these slow, late-night ramblings of mine help you drift off, a little tap on that like button, and maybe a subscribe, means more than you know. This is a small, quiet channel. Just an old man and a porch light and whatever's keeping you up tonight. And small creators like me really do lean on your support to keep the lights on. To everyone who's already here with me night after night, thank you, truly. You're the reason there's a porch at all. And tell me, while you're settling in, where in the world are you listening from tonight? What time has it gotten to in your corner of the dark? I always like to imagine all of you out there, scattered across the whole turning planet, all of you awake at the same... Well, we'll get to that. We'll get to whether the same time even means what you think it means. That's rather the whole point, isn't it? All right, let's begin, shall we? Nice and easy. Let me ask you something. It sounds like the simplest question in the world. So simple, it almost feels silly to say out loud. Here it is. What does the word now mean? Go on, sit with it a moment. Now. Right now, this instant, the present moment, you feel it, don't you? It's the most obvious thing there is. It's the realest thing you've got. The past is gone, slipped away behind you, nothing but memory. The future hasn't happened yet. It's still out there ahead in the fog, unknown and unfixed. And in between those two, there's this one thin, bright line where everything actually happens. The now. The present. It's where you live. It's the only place anyone has ever lived. You've never once in your whole life been anywhere but now. And here's what your gut tells you about it. What mine told me too for the longest time. Your gut tells you that now is universal. That it's shared. That when it's this moment for you, lying there in your bed with the blanket pulled up, it's also this very same moment everywhere else. This same instant is happening on the far side of your town. It's happening across the ocean where it might be the middle of the afternoon and people are going about their business, but it's there now too, the same now as yours, just lit differently by the sun. And surely, it's happening on the moon right now, the same now, and on Mars, and out past Mars, out among the stars, all the way to that great spiral of Andromeda hanging in the dark. There's a now happening there too, you'd think, the same now as this one. One single universal present moment, sweeping across the entire cosmos all at once, like a great invisible wave, carrying everything that exists forward together, in lockstep, tick by tick. That picture feels so obvious, so solid, so plainly true that it seems almost rude to question it. Of course there's one now for everybody. Of course the present moment is shared by the whole universe. What else could it possibly be? The sun is shining on Andromeda right now, isn't it? At the same time, it's this moment for you. Two things either happen at the same time or they don't. Surely that's just true. A fact. The way 1 + 1 is 2. This is the settled, comfortable, common-sense view of time that nearly every human being who has ever lived has carried around without a second thought. A single river of time flowing at one steady pace, carrying all of us along together. Your now is my now is everybody's now, all the way out to the edge of everything. It's so deep in our bones that we built our whole language around it. We say meanwhile, we say at the same time, we say right now across the world. Every one of those little phrases quietly assumes there's a shared, universal present that stretches across all of space, the same for everyone, everywhere, always. And it is wrong, not a little wrong. Not wrong in some tiny technicality you could safely ignore. It is wrong all the way down, in its bones, in its deepest foundation. There is no universal now, there never was. The thing your gut is most certain of. The one solid floorboard you'd swear you could stand on isn't there. And the strangest part, the part that took the cleverest minds in human history to even notice, is that the universe hid this from us so well, so thoroughly, that we lived with the illusion for thousands and thousands of years and never once caught it slipping. We never caught it because here on Earth, walking slow, talking to the people right beside us, it makes absolutely no difference. The crack only opens up when you go very, very fast or look very, very far away. And we never did either of those things. Not until a quiet young man working in a patent office in the year 1905 sat down and thought it all the way through. His name was Albert Einstein. You knew it would be, didn't you? It's always him. In that year, 1905, he published a paper with a title so dry and modest you'd never guess it was about to pull the floor out from under the whole human race. He called it On the Electrodynamics of Moving Bodies. Sounds like a manual for fixing engines, and buried in it was the idea we now call special relativity. And the whole thing, the whole vertiginous, beautiful, terrifying thing we're going to wander through tonight, it all grows from one single seed, one fact about the universe, one number. Let me give you that number gently, because it's the root of everything else. There is a speed, the speed of light. It's how fast light travels through empty space, and it is fast, about 300 million meters every second. The exact figure, if you want it, is 299,792,458 meters per second. We just call it Tsi. A little lowercase letter, Ixiang, standing in for that enormous number. Fast enough to circle the whole Earth more than 7 times in a single second. Fast enough that light from the sun, which is so far away, it takes that light 8 whole minutes to reach us, still feels to us like the sun lit up the sky instantly the moment it rose. Now here's the thing about that number that broke everybody's brain. And I want to go slow here because this is the hinge the whole night swings on. You'd think a speed is a speed. You'd think it depends on how you're moving when you measure it. That's how every other speed in your whole life works. If you're standing still on a platform and a train rushes past you at 100 miles an hour, the train is going 100 miles an hour, fair enough. But if you start running alongside it, even just jogging a little, the train pulls away from you a touch slower, doesn't it? Relative to you now, it's only going 90-something. And if you somehow ran exactly as fast as the train, it'd seem to sit still right beside you, not moving at all. You could reach out and touch the window. Speeds add up and cancel out. That's common sense. That's how throwing a ball from a moving car works. The ball gets the car's speed plus your throw. Everybody knows this. It's so obvious it doesn't even feel like a fact. And here is where the universe does something it has absolutely no right to do. Light does not behave like that train, not even a little. It turns out, and this has been tested and tested and tested until there's no wiggle room left in it at all, that no matter how you're moving when you measure it, you always get the very same number for the speed of light. Always. So, that same 299 million and change every single time. Stand still and measure a passing beam of light and you get Tsi. Now go chasing after that same beam at a tremendous speed, faster than any rocket, faster than anything, and measure it again. Does it pull away slower the way the train did? No, it still races away from you at exactly Tsi, the full speed, not one bit slower, as if you weren't chasing it at all. Let that sink in for just a moment. In the dark, with your eyes closed, you chase the light as hard as you possibly can, and it runs from you at exactly the same speed as if you were standing perfectly still. And the person standing still behind you, watching the very same beam, measures it at exactly that same speed too. You two are moving differently. You're racing, they're resting, and yet you both clock the light at precisely the same number. The light simply refuses to play the addition game. It will not be caught up to, it will not be slowed down, it will not be hurried along. To everyone, everywhere, no matter how they move, light travels at c-arms. This is called the invariance of the speed of light. Invariant just means it doesn't change, or it stays the same for everybody, no matter what. And I know it sounds impossible. I know it breaks the train and the running and the ball from the car and everything else your hands have ever taught you about how the world moves. It broke that for Einstein too. But he did something most people don't do when the world stops making sense. Instead of saying, "That can't be right," he said, "All right, suppose it is right. Suppose the speed of light truly is the same for everyone, no matter how they move. What would have to be true about the world for that to work?" And the answer he found is the reason you're lying there listening to an old man on a porch tell you that now isn't real. Because think about what a speed actually is. A speed is a distance divided by a time. Miles per hour, meters per second, so far per so long, distance over time. That's all a speed is, a stretch of space measured against a stretch of time. And if the speed of light has to come out the same for everyone, no matter how they're moving, but two people who are moving differently are covering different amounts of distance, and the light is covering different amounts of distance relative to each of them, then something has got to give. The arithmetic demands it. If the speed at the bottom of the fraction is locked, fixed, unbudging, the same for both of them, but the distances they each see are different, then the times have to be different too. They have to be. There's no other way to keep the speed of light the same for both of them. The space stretches and the time stretches to keep that one number, 6, sitting perfectly still in the middle of it all, like a stone in a river that the water has to bend around. So to keep the speed of light the same for everybody, space and time themselves have to bend and shift and slide depending on how you're moving. Time is not the fixed, universal, ticking the same for everyone thing your gut swears it is. Time is part of what gives to protect that one unbreakable number. And the very first thing to crack, the very first piece of your common sense clockwork to fall away once you accept that light goes the same speed for everyone, is the idea that two people can agree on what's happening at the same time. Now, I told you we'd go slow and I meant it, so let me make this real. Let me tell you the little story Einstein himself used to explain it back in 1916, when he wrote a book trying to make all this make sense to ordinary folks like you and me. It's a story about a train and a long stretch of railway embankment running alongside it. And it's so simple a child could picture it, but it carries the whole secret inside it. So picture it with me, slowly, in the dark. There's a very long train racing along a straight track, and there's a person standing on the embankment beside the track, just standing there, watching the train rush by. We'll call them the embankment watcher. And there's another person sitting right in the exact middle of the train being carried along with it, the train rider, right in the middle, equal distance from the front of the train and the back. Now 2 bolts of lightning come down. One strikes the very front of the train, the other strikes the very back in the same instant, and they leave scorch marks on both the train and the embankment, so we can come back later and measure exactly where they hit. Both ends of the train, lightning front and back. The person standing on the embankment is positioned so that they're exactly halfway between the 2 scorch marks on the ground. The flash from the front and the flash from the back each have to travel the same distance to reach their eyes, and the light from both flashes, traveling, remember, at exactly t the same speed, reaches the embankment watcher at the very same moment. Both flashes arrive at once. So the embankment watcher says, quite reasonably, those two lightning strikes happened at the same time. They were simultaneous. The front and the back got hit in the same instant. Case closed.
But now think about the person on the train rider sitting in the middle, being carried forward toward the front of the train, away from the back, while the light from those two flashes is traveling inward to find them. The train rider is moving. They are rushing forward toward the flash that came from the front of the train and away from the flash that came from the back. So the light from the front, which they're racing toward, reaches them first, and the light from the back, which they're pulling away from, has to chase them down and arrive a little later. Now here's the trap everybody's mind falls into, so let's step around it carefully. You want to say, but that's just because the train rider was moving, so the timing got distorted, but really, the strikes were simultaneous. The embankment fellow had it right. The train rider just got fooled by their own motion.
But no, that's the whole point. That's exactly the thing Einstein wouldn't let himself say, because the light travels at exactly c for the train rider too. Not by plus the train's speed, not minus anything. Exactly, say, the same as for everyone. The train rider has every right to consider themselves perfectly still, and the embankment to be the thing that's rushing by outside the window. There's no experiment they can do, sealed up inside that train, to prove they're the one that's really moving. And measuring the same speed CAS for both flashes, and seeing the front flash arrive first, the train rider must conclude, correctly, with iron logic, that the lightning struck the front of the train before it struck the back. They were not simultaneous. The front one came first. So now look at what we've got. The embankment watcher says the two strikes happened at the same time. The train rider says no, the front one happened first. And there is no way, none, to declare one of them mistaken. They each measured the light at the same speed, exactly as the universe demands. They each reasoned flawlessly from what they saw. The embankment watcher isn't wrong. The train rider isn't wrong. They simply disagree about whether two events happened at the same time, and the universe offers no tiebreaker. There is no fact of the matter floating above them both about which one is really right. Both nows are real. Both nows are valid. They just aren't the same now. That right there, that quiet little disagreement between a person on a train and a person on a hillside, has a name. We call it the relativity of simultaneity. Simultaneity just means two things happening at the same time, and it turns out simultaneity is relative. It depends on who's asking, on how they're moving. Whether two separated events happen at the same time is not a fixed feature of the universe. It's a thing that changes depending on your motion. Move differently, and the very list of events you'd call happening now quietly rearranges itself. And I know what you might be thinking half asleep there. You're thinking, all right, Grandpa, but the train rider only disagrees with the hillside fellow by the tiniest sliver of a second. A train goes fast, sure, but it's nothing next to the speed of light. The whole disagreement is so small you could never even notice it, and you'd be right. On a train, the gap between their two nows is so absurdly tiny, a sliver of a second, that no human being could ever feel it. That's exactly why we never noticed any of this for all those thousands of years. Down here, walking slow, riding trains, living our small close lives, the cracks in now are far too fine to see. But that little disagreement does not stay little. It has a way of growing in a particular way, with a particular ingredient, until it becomes the monstrous thing I showed you at the very start, the thing on the sidewalk where one step apart means days of difference across the gulf to Andromeda. The train and the embankment are where the crack first appears. They are the first concrete proof that now is not shared. And once you've truly seen that crack open, even by a sliver, even on a train, you can never quite trust the floorboards of now again. So that's the seed. A simple thing, really. Once you walk up to it slowly, the light goes the same speed for everyone. To keep it that way, time has to bend. And the very first thing that bends is everyone's agreement about what's happening at this very moment. Now, the question that's surely forming in the back of your sleepy mind, and the question that's going to carry us into the rest of the night, is this. If a train can make two nows disagree by a sliver of a second, what could make them disagree by days? By years? What turns that harmless little crack into the chasm I opened with, the one wide enough to swallow the day you were born and the day you'll die, and set them both as someone's now? The answer isn't speed. That's the surprise waiting for us. The answer is something far gentler, far quieter, far stranger than speed. But that we'll come to, slowly, in just a little while. For now, settle back into the train with me a moment longer, because there's a tender little detail in it worth holding before we move on. When the embankment watcher and the rider disagree, neither of them is making a mistake. That's the part that's hard to swallow at first, and easy to swallow once you're half asleep and not fighting it. We're so used to the idea that when two people see the same thing differently, one of them is wrong. One's clock is fast. One blinked. One stood too far away. But here, with the lightning and the train, there's no tiebreaker hiding somewhere who knows the real answer. There's no referee in the sky with the true stopwatch. The embankment watcher is right that the flashes were together. The rider is right that the front came first. And the universe simply shrugs and says, yes, both, and offers you no third opinion to settle it. That absence, the missing referee, is the thing I want to lay in your hands tonight, because everything else we'll wander through grows out of it. There is no master clock. There's no single great pendulum swinging somewhere at the center of everything, ticking out the one true now that all of us are secretly keeping time against. Einstein looked for the simplest, most innocent seeming rule he could find, that light goes the same speed for everyone, always, no matter how you chase it. And he followed it honestly to the end. And at the end of it was this quiet, enormous demolition. The universal now, the thing you've leaned on your whole life without once thinking about it, the thing that feels as solid as the bed beneath you. Gone, not hidden, not too small to measure, just not there.
And I know. Part of you is lying there going, but it has to be there. It feels like it's there. Right now, this instant, surely something is happening on the far side of the world, this very second, simultaneous with my breathing. Surely there's a fact of the matter about what's happening now on the moon, or out past Jupiter, or in some quiet corner of Andromeda. It feels almost rude to suggest otherwise.
That feeling, that deep certainty, hold on to it loosely, the way you'd hold a warm mug you're about to set down. Because the whole gentle business of these next hours is the slow, kind unlearning of it. Here's the thing about that certainty, though. It isn't stupid. It isn't a silly mistake people make. It's earned. For your whole life, every now you've ever shared with anyone has been close. The person beside you on the couch, the voice on the phone, which feels instant even though it isn't quite. Your reflection, your own two hands. At human distances, it is across a room, across a town, even across an ocean. The disagreement between your now and theirs is so unimaginably tiny that no clock you'll ever hold could catch it. So of course it feels absolute. Of course it feels like there's one shared present we're all standing in together. The crack is real, But down here it's finer than a hair, finer than a thought, and your whole life has been lived inside that smallness. You were never wrong to feel it. You were just never far enough away to feel it break. That's worth sitting with, I think, as the train pulls quietly out of our story. 2 flashes of lightning. A man on a bank, a woman on a train. A disagreement about a single instant that's true for both of them and false for neither. So small you'd never notice. And yet, this is the part to carry into your dreams. It's the same disagreement. The very same one. The crack between the riders now and the watchers now is made of the exact same stuff as the chasm that swallows whole days out on the road to Andromeda. Not a different effect, not a bigger, scarier cousin, the same crack, the same gentle rule about light. The only thing that changed between the harmless train and the monstrous sidewalk is one ingredient I keep promising you and keep deliberately not naming yet. You might already be reaching for it. You might be thinking, well, it's speed, isn't it? The train was slow, so make something go fast, faster, near the speed of light, and surely that's kind of what cracks the now wide open. It's the natural guess. It's the one almost everyone makes. And it's wrong, and the wrongness of it is one of the loveliest little surprises in all of this, the kind of thing that makes you go, oh, very quietly in the dark. Because the 2 strangers on that sidewalk weren't moving fast. They were walking, strolling really. One of them may be pausing to look in a shop window. The difference in their motion was the difference between an idle wander one way and an idle wander the other. A few footsteps worth of speed, less than a breeze. And out of that nothing, that almost stillness, came days. Days of difference in the launching of a fleet across 2.5 million light years. So it can't be speed alone. Something else is doing the heavy lifting, something so quiet you'd walk right past it, which is exactly what those 2 strangers did. And we'll find it, you and I, the way we find everything here. Not by rushing at it, but by drifting up to it slowly until it's standing right in front of us, and we wonder how we ever missed it. There's no hurry at all. The fleet, if there is one, isn't going anywhere, or rather, it's going everywhere and nowhere depending on which way you're facing, which is the whole maddening, beautiful point. But before we chase that gentle ingredient, I want to give you the floor to stand on, the honest one, because it would be the easiest thing in the world for me to make all this sound like a magic trick, a riddle, a gotcha. And it isn't. This is the most tested, most relied upon physics there is. None of it is a thought experiment that stayed in someone's head. We built our world on it without most people ever knowing. And that, the realness of it, the solid ground underneath all this strangeness, is where we'll set our feet next. So that when the vertigo comes, and it will come, you'll know the floor is real even as it tilts. Rest your eyes if they want resting. I'll still be here talking softly when you drift back. So let us begin with the thing that forces all the rest of it. The single, quiet rule from which everything, the disagreements, the tilted slices, the alien fleet, the days of difference on a sidewalk, flows without exception. It isn't complicated, or rather, it is enormously complicated in its consequences, but the rule itself sits in one sentence. The speed of light is the same for everyone. That's it. That is the load-bearing beam under this whole strange house. The speed of light, 299,792,458 meters per second, does not change depending on who is measuring it. It does not add to your own speed the way a ball thrown from a moving car adds to the car's speed. If you are standing still and you shine a flashlight, the light leaves at 299,792,458 meters per second. If you are on a train moving at half the speed of light and you shine a flashlight forward, the light does not travel at 1.5 times the speed of light. It still leaves you and it arrives at its destination at exactly 299,792,158 meters per second. Your motion doesn't help it, doesn't slow it either. It just goes, always at exactly that, as if the universe has a rule carved into its floor that nothing, no speed, no frame, no amount of will or engineering can touch. Albert Einstein stated this as the second of his two founding postulates in 1905 in the paper on the electrodynamics of moving bodies. The first postulate was that the laws of physics are the same in every inertial frame, every frame moving at constant velocity. The second was the strange one, the invariance of c. And from those two postulates together, everything we are about to look at follows with mathematical certainty. Now here's the thing, here's where the floor starts to feel interesting beneath your feet. If the speed of light is the same for everyone, truly the same, measured identically by someone standing still and by someone hurtling through space, then something else has to give. The universe can't hand you that invariance for free. It has to pay for it somewhere. And what it pays with is agreement. The universe gives you the same speed of light, and in return, it takes away the shared clock. It takes away the universal now. Think about what same speed actually means. Speed is distance divided by time. If two people measure the same speed for the same light beam, and they are moving relative to each other, then at least one of their distances or times must be different. You can't both get the same number out of different distance and time combinations unless the ingredients are different. So either their rulers are different, or their clocks are different, or both. And the answer, as Einstein worked out, and as every experiment since has confirmed, is both. Rulers in motion are shorter. Clocks in motion are slower. And perhaps most strangely of all, clocks in different places that are moving relative to each other are offset. They disagree not just about the rate of time, but about which events count as happening at the same moment. That last one is the relativity of simultaneity, and it is the engine of everything in this video. Let's visit the thought experiment Einstein himself used to introduce it. Not the sidewalk, not Andromeda, those come later, and they are more vivid, but Einstein's own picture, the one he put in his 1916 book, simply called Relativity, the Special and the General Theory. He imagined a train, long and straight, moving along an embankment, and at the moment the exact midpoint of the train passes an observer standing on the embankment, lightning strikes both ends of the train simultaneously, or so the embankment observer would say. Now, the light from both strikes travels toward the embankment observer from both directions, and since the observer is exactly in the middle of where the two strikes landed, the two light flashes arrive at the same moment. Equal distances, same speed of light, equal travel times. Simultaneous, the embankment observer says with confidence, both at once. But there is also an observer in the middle of the train, and the train is moving. Moving, let's say, toward the front strike and away from the back strike. The light from the front strike, from the observer, on the train's perspective, has a shorter distance to travel before it reaches her, because she is moving toward it. The light from the back strike has a longer distance. She's moving away from it. And since the speed of light is the same for her as for everyone else, she cannot give it a boost from the train's own velocity. That is the whole point. The light from the front arrives first. She sees the front strike before the back strike. She says, the front lightning came first. The embankment observer says they were simultaneous, and neither of them is wrong. This is not a measurement error. It is not confusion about signal delay. It is not that one of them really knows and the other is mistaken. Both answers are physically valid in their respective frames of motion. The events, the two lightning bolts, are simultaneous in one frame and not simultaneous in another. And this is not a paradox or a flaw in the theory. It is an exact, verifiable mathematical result. This is what Einstein was telling us. The "at the same time" you say so casually, it's the "at the same time" that feels as obvious as breathing, is a frame-dependent statement. It depends on how you are moving. Two events that are simultaneous for you are, in general, not simultaneous for someone moving relative to you. And the universe allows this because it is protecting something more fundamental than your intuition of now. It is protecting causality. It is protecting the rule that causes come before effects, that you can't receive a telegram before it was sent. The universe gave up shared simultaneity so it could hold the line on something even more important. But we'll get to that firewall. Don't rush toward it. It'll be waiting. Right now, let's look at the mathematics, because the mathematics is not frightening. It is actually quite beautiful once you see what it is doing, and it is the only way to understand why distance amplifies everything so ferociously. The Lorentz transformation is the set of equations that tells you how to translate time and space measurements from one moving frame to another. You don't need to be able to work the equations, but there is one piece of one equation that I want you to notice because it is the key to the whole puzzle. When you calculate the time of an event as seen from a moving frame, let's call the original time t and the new time t prime. The new time is not simply t adjusted for speed. The equation for t prime contains a term that also involves x, position, where the event happened in space. The term looks like this. T prime equals gamma multiplied by the quantity t minus vx divided by c squared. The part that matters most for us tonight is that minus vx over c squared, the minus, the x, the c squared. What this term says is, to find out whether something is in your now, you need to know not just when it happened, but where it happened, and how fast you are moving relative to it. The time of a distant event in your frame depends on its location. Think of what that means. If something happens very close to you, but if x is very small, then vx over c squared is very small, nearly negligible, no matter how fast you are moving. The event's when barely shifts. But if something happens very far away, if x is enormous, then even a tiny v, a tiny velocity, can produce a large shift in t prime. The time coordinate of the event changes substantially. Distance is the amplifier, not speed. Distance. And this is why the sidewalk does something that a rocket doesn't. A rocket can travel at thousands of meters per second, but if it's looking at something only a few hundred kilometers away, the vx over c squared term is still tiny. The offset in simultaneity is tiny. You'd never notice it. But a person walking at 1 meter per second, barely moving, drifting really, is looking at something 2.5 million light years away. That x is gigantic. And so even though v is almost nothing, the product vx is vast. Divide by c squared, which is a very large number but not infinite, and you get an offset that is not small at all. Let's do the arithmetic together, not quickly, and there's no need to rush through it. Let's just let the numbers land where they land. 1 meter per second is your walking pace, a leisurely stroll. You are moving at v equals approximately 1 meter per second. The speed of light, c, is 299,792,458 meters per second. So your v divided by c, your speed as a fraction of light speed, is about 3.3 times 10 to the minus 9. That is 0.00033. A number so small it barely deserves a name. A fraction of a fraction of a fraction of a fraction of the speed of light. Now, the Andromeda galaxy is approximately 2.5 million light years away. 1 light year is the distance light travels in a year, which is about 9.46 times 10 to the 15th meters. 2.5 million light years is, therefore, a distance x of roughly 2.5 million times 9.46 times 10 to the 15th meters. That is a very large x. The simultaneity offset, the shift in which moment counts as now, on Andromeda between you and someone moving at 1 meter per second relative to you, is approximately x over c multiplied by v over c. Let's keep it in light years for simplicity, because x over c is simply the distance in light years when we're measuring time in years. So 2.5 million light years multiplied by 3.3 times 10 to the minus 9, and that product is approximately 0.083 years, which is approximately 3 days. 3 days, a walking pace, 1 meter per second, and the present moment on Andromeda shifts by 3 days. Take a breath. Let that sit for a moment. There's no hurry. Now try a different distance. Let's say instead of Andromeda, you were looking at a galaxy 1 billion light years away, still walking at 1 meter per second. Same calculation, 1 billion multiplied by 3.3 times 10 to the minus 9 equals 3.3 years. The same slow walk, the same lazy Sunday stroll, and the now on that distant galaxy shifts by more than 3 years. 3 years. From walking, and if you go farther, 10 billion light years, which is not approaching the limit of what we can observe, the same walk gives you 33 years of offset. You and your neighbor on the sidewalk, one of you walking left, one walking right, disagree about a present moment on a sufficiently distant object by more than 3 decades. Their now out there includes things that in your now are deep in the future or deep in the past. The math is unforgiving. It has no exceptions. It does not care about intuition. It scales without limit with distance, and the observable universe is very, very large. Now, I want to pause here because you might be feeling the beginning of something uncomfortable, not frightening, I hope. More like a loose floorboard, a slight wobble in something you'd thought was solid. That feeling is good. That is the honest response to what the equations are actually saying. But I also want you to rest with it gently. None of this is happening to you right now in a way that disturbs anything about your immediate experience. You're now in this room, wherever you are, whatever lamp is still burning, whatever quiet has gathered around you, is real and unambiguous and yours. It is only when you reach out across cosmic distance that the agreement falls apart. Close to home, physics is almost perfectly well behaved. It is only when you stretch it across the universe that it begins to show you its stranger face. So let's stretch it a little more, but slowly. The man who gave us the geometry to hold all this in mind, who gave us the proper mathematical home for what Einstein discovered, was Hermann Minkowski. Minkowski was a mathematician, not a physicist. Einstein had actually been a student of his, and Minkowski at the time had reportedly not thought especially highly of the young Einstein's diligence in class. So when Einstein produced special relativity in 1905, Minkowski did something remarkable. He looked at the equations and saw that they were telling a geometric story. They were not just equations about light and clocks. They were equations about the structure of reality itself. In September of 1908 in Cologne, Minkowski stood up and delivered an address. It was called Raum und Zeit, Space and Time, and he opened it with a declaration that has probably never been improved upon as a way of putting the situation plainly. He said, "Henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. Space by itself, a shadow. Time by itself, a shadow. Only their union. Space-time is real." This is Minkowski's space-time, the arena in which everything in this video lives. In Minkowski's picture, you don't have 3 dimensions of space plus time ticking along separately in the background. You have 4 dimensions woven together into one fabric. Every event, not just every object, but every event, everything that happens anywhere at any point in time, has 4 coordinates, 3 of space and 1 of time. And these 4 coordinates are not independent in the way your intuition wants them to be. They mix. When you move through space, you rotate through space and time together. When you change velocity, you are not just changing where you go, you are changing your orientation in 4-dimensional space-time. And this is where the now slice comes in. Imagine all of space-time laid out, every event that has ever happened, every event that is happening, every event that will happen, all of it, the entire universe from the Big Bang to whatever comes last, all existing together in this 4-dimensional fabric. You, sitting or lying wherever you are right now, exist as a path through that fabric. Your whole life from birth to death is a single continuous line through space-time. Physicists call it a world line, your world line, threading through time and through the positions in space where you have been and will be. Now, your now is not a point on that line. Your now is a whole slice through the fabric. It is the collection of all events across the entire universe that are, in your current frame of motion, happening at the same moment as this moment. A slice through all 4 dimensions that cuts out all 3 dimensions of space at one particular time. Physicists call this a hypersurface of simultaneity, or a plane of simultaneity, or simply a now slice. It is, in your experience, everything that is happening right now, the star 5 light-years away whose light you'll never see, the planet around a distant star where, for all we know, nothing is happening at all. All of it, the entire infinite or very large sweep of space at this moment. That is your now slice. And here is what changes everything. When you change your velocity, when you accelerate, when you turn around, when you speed up or slow down, your now slice tilts. It is not the same hypersurface. It slices through the space-time fabric at a different angle. Think of it this way. Imagine you are holding a piece of paper flat, horizontally, and you slowly tilt it. The paper now cuts through the same block of space, or call it a loaf of bread, as Greene does in his beautiful book, The Fabric of the Cosmos, published in 2004. The paper now cuts through the loaf at a different angle. And different crumbs, different raisins, different points inside the bread are now on your slice. Change the angle and you get a different cross-section. The bread is the same, the loaf doesn't change, but what you call this slice right here, the one I'm cutting, is entirely different. Greene's loaf of bread is exactly the right image, and I want you to hold it for a while because we'll come back to it. Space-time is the loaf. Your now is a slice. Every observer cuts their own slice, and observers moving relative to each other cut at different angles. The loaf is the same for everyone. Every event in space-time exists in the loaf. Nothing is added or removed based on who is looking. But what is in my present moment? Which events I include in my now slice? That depends entirely on how I am moving. 2 observers moving differently through the same loaf will carve out different nows. They will include different events in their "this is what is happening right now." And because the loaf is enormous, because the universe is very, very large, a tiny difference in the angle of the cut makes an enormous difference in which events end up in the slice. Walk one way down the street and your now slice through space-time tilts very slightly in one direction. It includes one set of distant events in your present. Walk the other way and it tilts very slightly in the other direction. For anything nearby, the coffee mug, on your nightstand, the traffic light down the road, the tilt is imperceptible, negligible, unmeasurable by any clock we have or could build. Those nearby events stay in everyone's now regardless. The geometry only reveals itself at distance, but at the distance of Andromeda, 2.5 million light-years, the tiny tilt that almost nothing difference in the angle of your personal now slice sweeps across days of events on that distant galaxy. Days of what is, for us here, the future? Or the past, but which is, for one or the other of those two people on the sidewalk right now. And we have not yet arrived at the most vertiginous piece of this. We have been talking about two people walking, moving steadily at constant velocity, at a pace a child could match. But what happens if someone, sorti or something, is not just moving at constant velocity, but changing its velocity? What if it is accelerating? When you accelerate, you change your velocity. And when you change your velocity, your now slice tilts continuously. It does not stay at one angle, it sweeps. It moves through the loaf. Events that were in your not yet a moment ago can slide into your right now. Events that were in your right now can slide into your already past. For nearby events, this sweeping is so small as to be utterly undetectable. But for events very far away, at the scale of hundreds of millions or billions of light years, the sweeping of a gently accelerating object is staggering. This is the thing the title is about. This is the literal claim. A being in a distant enough galaxy changing its motion even gently, not rockets, not relativistic speeds, just a modest change in velocity, the kind of thing that happens naturally as galaxies move and rotate, has a now slice that does not point at one fixed moment in Earth's history. Its now slice sweeps. And if the galaxy is far enough away, that sweep covers not years of Earth's history, but millennia. Not millennia, the whole observable span of a human life. Your birth and your death might both fall within the range of events that count as right now for that distant being, depending on which way it is drifting. This is not poetry. This is the direct mathematical consequence of the Lorentz term, that minus Vx over c squared, which we sat with earlier, applied to the geometry Minkowski set out in Cologne in 1908. The Rietdijk Putnam argument, worked out independently by the philosopher C.W. Rietdijk in 1966 and the philosopher Hilary Putnam in 1967, and made viscerally tangible by Roger Penrose in his 1989 book The Emperor's New Mind, is simply the working out of what these equations imply when you take them seriously. Penrose's version is the one I love most because it uses a specific and startling image. He asks you to think about the alien invasion fleet, the fleet that may or may not be launching from Andromeda. For the person walking toward Andromeda on that sidewalk, the now slice angles forward slightly in Andromeda's direction, and the events it intersects on Andromeda are slightly farther into Andromeda's local future. The fleet in this person's present has not yet launched. The decision has not been made. For the person walking away from Andromeda, the now slice angles in the other direction, backward in time from our perspective, and the events it intersects on Andromeda are slightly farther into Andromeda's local past. The decision in this person's present was made days ago. The fleet is already on its way. They are on the same sidewalk. They pass within arm's reach, and for one of them the fleet doesn't exist yet. For the other, it's been moving for days. Now I want to be careful here because the precise and rigorous version of this is important. We are not saying that one person has the correct Andromeda and the other has a wrong one. There is no correct version. The geometry of space-time does not single out one now slice as the real one. Every observer's now slice is exactly as valid as every other's. Minkowski's space-time is democratic in that sense. It has no preferred slicing. No God's eye view that declares this moment and not that one to be the true present across the universe. This is also what Einstein meant when he said, as the first postulate of special relativity, that the laws of physics are the same in every inertial frame. There is no privileged observer, there is no reference frame that has access to a truer time than any other. The embankment observer is not more correct than the train observer. They simply have different now slices, both equally valid, both equally physical. And Minkowski gave us the mathematics to hold this elegantly, without contradiction, without paradox, because he showed that the thing that is invariant, the thing all observers do agree on, is not the time between events and not the space between events, but a combination of the two, the space-time interval. The geometry of the fabric itself is agreed upon. Only the particular way you slice it reflects your motion. So the now slice is not fixed to the universe. It is fixed to you, and it follows you wherever you go, tilting and sweeping with every change in your velocity, pointing at different moments in the history of the cosmos, depending on how you move through it. Your now, in the most honest physical sense, is a local thing. It belongs to where you are and how you are moving. Physics does not provide a master clock, ticking away somewhere above the universe, stamping each event with an absolute time that everyone must agree on. Einstein demolished that clock in 1905. Minkowski buried it with geometry in 1908, and every experiment since has confirmed the demolition. It is worth pausing here to ask the question you may already be asking. Not the big philosophical questions, that's coming gently later, but the practical one. Why don't we notice any of this? Why does now feel so perfectly singular, so obvious, so beyond question? Why does simultaneity feel universal when the equations say it isn't? Because we don't move fast enough, and because we are very small, our lives unfold at speeds that are tiny fractions of the speed of light. The fastest we routinely travel on a commercial aircraft at roughly 900 kilometers per hour is less than 1/1,000,000th the speed of light. And the things we call simultaneous in everyday life, the clap of a hand, the striking of a gong, two events across a room, are separated by distances measured in meters, not light years. When x is measured in meters and v is measured in meters per second, and c is nearly 300 million meters per second, the vx over c squared term is absurdly, immeasurably small. It is there, it is real, but it is so small that no clock we will ever build could detect it in everyday life. Expand the distance to cosmic scales and the term explodes into visibility. Shrink back to human scales and it collapses into perfect invisibility. Our intuition of a universal now is not wrong in the sense of being a delusion. It is an extremely accurate approximation for the speeds and distances that matter to creatures like us. It is like saying that the ground is flat because for the distances we walk in our daily lives, it is flat enough. The Earth's curvature doesn't reveal itself when you step from your front door to your mailbox, but it reveals itself when you try to fly from one side of the planet to the other. The curvature was always there, you just couldn't see it from where you were standing. And this brings us to the moment where the idea of simultaneity opens out into something much larger. A question that Hermann Minkowski's geometry raises and does not answer, because it is not a question for geometry, but for philosophy, and for physics at its most speculative. If there is no universal now, what is the nature of time itself? What is real? Here is where space-time's geometry makes its most unsettling suggestion. In Minkowski space-time, all four dimensions are laid out. All events exist as points in the fabric. Your past exists in the fabric. Your future exists in the fabric. The events of ancient Rome exist in the fabric. The events of whatever will happen 1,000 years from now exist in the fabric. They are all simply there as the structure of the space-time loaf, whether or not you have arrived at them yet, whether or not anyone is experiencing them. The flow of time, the sense that the present is moving, that the past is receding and the future is approaching, is not a feature of Minkowski's space-time. Space-time does not flow, it simply is. The mathematician or physicist working in space-time does not describe time as passing. They describe world lines that extend in the time direction, events that are separated by time intervals, light cones that open in both temporal directions. Time is a dimension, not a current. And if that is true, if space-time is static, if all events simply exist, then the past is not gone and the future is not yet to come. They are all there, equally, in the four-dimensional fabric. Your birth exists in the fabric. This moment exists in the fabric. The last moment of your life exists in the fabric. They are all equally real in the sense that the mathematical structure of space-time contains them all. This is what physicists and philosophers call the block universe, or eternalism. And it is not a fringe idea or a pop science speculation. It is the most straightforward reading of what Minkowski space-time implies, and it has been endorsed by serious physicists including Brian Greene himself in The Fabric of the Cosmos. And it was arguably the position Einstein held when he wrote, in March of 1955, just weeks before his own death, to the family of his lifelong friend Michele Besso, who had just died. Einstein wrote, "People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion." A stubbornly persistent illusion. Einstein believed that the distinction between past, present, and future, the very structure of your experience of time, was not a feature of physical reality but of human perception. That in the fabric of space-time there is no before and after that the universe itself honors. Only events at coordinates, all equally existing. We'll come back to that letter. It deserves more time and a quieter moment, but I want you to hold the shape of it for now, because we are not yet done with the geometry. There is still the question of what exactly a now slice is, and how a small change in motion sweeps it through the loaf. And this has a beautiful precision that I don't want to rush past. Your now slice, your hypersurface of simultaneity, to give it its full name, is a three-dimensional surface embedded in four-dimensional space-time. Think of it as all of three-dimensional space, frozen at one instant. If you could somehow take a photograph of the entire universe at one moment, snap everything, every particle, every galaxy, every quantum of light at one time, that photograph would be a now slice. It is a vast three-dimensional sheet cutting through the four-dimensional loaf. Now, in space-time, the way your motion orients you is analogous to the way turning your head in ordinary space orients your vision. When you turn in space, north becomes east, becomes south, and what was in front of you changes. When you change velocity in space-time, your time direction tilts relative to the fabric, and your now slice, which is always perpendicular to your time direction, tilts with it. Not in a way you can feel or see, not in a way that affects anything nearby, but mathematically, cleanly, unambiguously, the slice changes its angle. And when the slice is nearly horizontal through the loaf, when you are nearly at rest, and you're looking at a nearby part of the loaf, tilting the slice by a tiny amount doesn't change what's in it much. Just a thin sliver shifts in or out of the slice. The nearby events are so close to the slicing edge that a tiny tilt doesn't include or exclude any of them differently. But look at the far edge of the loaf. Look at the events that are far away in space, which in the loaf means events that are displaced sideways from you while being on a similar time layer. When your slice tilts, even just a little, the far edge of the slice moves a lot. Tilt a piece of paper by 1 degree and the near edge barely moves. The far edge moves much more, proportional to the paper's length. The hypersurface of simultaneity is like that paper. Tilt it by the tiny amount corresponding to walking pace and close to you, nothing changes. Far away, at the distance of Andromeda, tilt that far edge has moved by days. At the distance of 1 billion light years, it has moved by years. The now slice is a lever, and distance is the lever arm. A small rotation at the fulcrum, at your own location, produces a vast sweep at the far end. This is not a metaphor. This is exactly what the Lorentz transformation is saying when it writes t prime equals gamma times the quantity t minus vx over c squared. The x in that formula is your lever arm. The v is the angle you're tilting the slice. The product vx over c squared is how far the far edge of your slice has moved from where it was before. Let's make this personal one more time before we move on. You are here now, reading or listening to this. You have a now slice. It passes through this room, through your bed or your chair, through the city you're in, through the surface of the Earth, out into space, through the solar system, out through the galaxy, out to Andromeda, out to distant clusters of galaxies, out to the very edge of the observable universe. Your now slice is, in principle, infinite, or at least as large as the observable cosmos. Everything in your now slice is, by definition, in your present moment. The light from those events has not yet reached you. You can't see them, can't know about them, can't affect them, and they can't affect you. Not yet. But in the geometry of space-time, in the structure of what is simultaneous with this moment for you, they are in your now. And if you stood up right now and walked to the kitchen and walked back, if you changed your velocity briefly and then changed it again, your now slice would tilt one way and then the other. The slice over Andromeda would sweep by days. The slice over that billion light-year galaxy would sweep by years. You in your slippers, in the quiet of wherever it is you are tonight, with your cup of something warm or nothing at all, would have swept the present moment across years of events on a far galaxy simply by getting up and walking back. The universe permits this. The equations require it. There is no override, no master frame, no absolute now to appeal to. Space by itself and time by itself are doomed to fade away into mere shadows. Minkowski said that in Cologne in September 1908 to an audience of scientists, and they must have felt something shift beneath their feet too. I imagine the room going quiet for a moment. I imagine the particular silence that falls when someone says a true thing that changes the shape of everything else. And we are still, you and I, only in the middle of the story. The geometry is laid out. The now slice has been tilted and swept. The arithmetic has been done. The days and years of difference have been counted. But we haven't yet talked about what it means to say the past is real, or whether the future already exists, or what Einstein really meant when he wrote that the distinction between past, present, and future is an illusion. And we haven't yet talked about the firewall, the one piece of physics that holds everything in place, that prevents any of this strangeness from tipping over into chaos, that keeps the universe strange but not lawless. Because that too is part of the story. The strangeness is real, the strangeness is vast, and the universe has a counterweight that you need to know about, one that will, I think, settle something that might be troubling you even now. But that is a conversation for a softer moment. Let the geometry rest for now. Let the loaf just sit there, infinite and patient, every event in every moment quietly present in the fabric. Let the now slice be what it is, yours here, tilted to the angle of your particular motion through space-time, pointing at this room and this moment, and at some distant galaxies yesterday or tomorrow, depending on which way you shift in your seat. It is quite something, isn't it, to think that now, the word you probably said 10 times today without a second thought, the most obvious, immediate, self-evident thing there is, turns out to be the one thing the universe refuses to agree on. Space and time doomed to fade, only the union remaining. And in that union, the present is not a river flowing from past to future. carrying everyone along in step. It is a slice, your slice. Personal, local, tilted by your motion, sweeping through the cosmic loaf every time you move. And the universe has been this way since before there was anyone to notice. It waited, very patiently, for Hermann Minkowski to give it the right language. And then it waited a little longer, quietly, for the rest of us to catch up. So let us talk about the loaf. Brian Greene, in his book The Fabric of the Cosmos, published in 2004, reached for this image because he needed something you could almost hold in your hands. Something with weight and texture and the right kind of ordinariness. Not a river, not a stream. Those images carry the sense of flow, of the present moving through time. And that is precisely the intuition he needed to dissolve. So he chose a loaf of bread. Picture it. A simple loaf, the kind with a good crust and a soft interior, sitting on a table. Every slice through that loaf from one end to the other is a different moment in time. The whole loaf, from the left heel to the right, contains every event that has ever happened and every event that ever will. Your great-grandmother's childhood, the construction of the Parthenon, the moment a star 100,000 light-years away will go dark in what we would call the distant future. All of it is there, baked in, already present in the fabric of the loaf. And your now, the thing you mean when you say the word today, or this moment, or right now as I lie here in the dark, your now is one slice. Just one slice. A flat plane cutting through the loaf from one side to the other, collecting all the events that exist at this moment in time, separating what has happened from what is yet to come. That slice is your present. That is your now. And here is the thing Greene wanted you to feel, the thing the geometry quietly insists upon. The angle of that slice is not fixed. It is not the same for everyone. Two observers moving differently through space-time, moving at different velocities relative to one another, cut the loaf at different angles, not wildly, dramatically different angles, not in everyday life. The difference is almost unimaginably small when you are talking about speeds we actually reach. But the loaf is also unimaginably long. And when you combine a tiny angular difference with a loaf that extends for billions of light years in every direction, the slices diverge. They separate. What falls into your now slice, what sits on the flat plane of your present, and what falls into the now slice of an observer moving differently from you can be very, very far apart. This is not metaphor. This is not a useful fiction invented to make the math friendlier. The slice is the mathematical object called the hypersurface of simultaneity, the plane of all events that are simultaneous in your frame of reference. And because the Lorentz transformation tells us that simultaneity is not preserved between frames in relative motion, because the term t equals g dot e vx 2 contains that irreducible distance-dependent piece that we talked about earlier, the hypersurface of simultaneity is genuinely, concretely, measurably different for observers moving at different velocities. You cut the loaf differently, and across cosmic distances that different cut falls on different centuries. Now, let us get to the thing the title of this video promised you. The thing I have been building toward, slowly, one layer at a time. Because we have done the setup. We understand why c being constant for everyone forces the Lorentz transformation. We understand how the vx 2 term translates a difference in velocity into a difference in which events are now for two observers. We understand the arithmetic in that a walking pace, something like 1 meter per second over a distance of 2.5 million light years, yields a simultaneity shift of roughly 3 days. That a galaxy 1 billion light years away magnifies that same walking pace into a shift of more than 3 years. So let us use that geometry to do what it actually does when you push it all the way to its conclusion. Somewhere out there, and this is not a fantastical hypothesis, this is a straightforward consequence of special relativity as formulated by Albert Einstein in 1905 and geometrized by Hermann Minkowski in 1908. Somewhere out there, there is a being. It does not need to be very exotic. It does not need to be moving at any impressive fraction of the speed of light. Give it, if you like, the same sluggish velocities we manage here on Earth. Put it in a galaxy far enough away, say several billion light years, and let it simply move. Let it drift. Let it go about whatever it does, shifting its velocity by small amounts as it orbits its star or travels between places or simply, as you might say, turns around. Each of those small changes in velocity tilts its now slice. Each tilt, amplified across the billions of light years between its galaxy and yours, sweeps the slice across an enormous stretch of Earth's history. And if the geometry is right, if the distance is large enough and the motion is persistent enough, that being's now slice does not hover politely near your own present. It does not share your Tuesday evening. It slides. It moves through Earth's timeline the way a beam of light moves through a darkened room, the way a sundial's shadow crosses a courtyard over the course of a day, steadily and without any particular drama, covering everything in its path. In one moment, by its own clock, by its own locally valid and physically real frame of reference, its now corresponds to the day you were born, the specific morning or afternoon or whenever it was. The particular events of that particular day on Earth are, by the geometry of Minkowski spacetime, simultaneous with its present moment, and in another moment, not long after by its reckoning, after some change in its motion, its now slice has tilted just enough. The arithmetic shifts, and now the set of Earth events that count as simultaneous with its present no longer includes the day of your birth. It includes a different day, a day much later in your life, a day, if we want to push this all the way to where it actually leads, that might correspond to the day you die, your birth, your death. Both in its now at different moments in its own experience, depending on how it moves. Take a breath. There is no need to rush past this. It is one of those ideas that deserves a moment of quiet. Just let it sit there. Your entire life, every year of it, every laugh and disappointment and ordinary Wednesday and significant turning point, the whole span of it is, from the right vantage and with the right motion, simply an interval within someone else's now. The beginning of it simultaneous with their present at one moment, the end of it simultaneous with their present at another. And the distance between those two moments, in the being's own experience, might be quite small. A shift in velocity, a change in direction, a slow drift that covers what is, by cosmic standards, not very much ground at all. This is the argument made independently by two philosophers working in the 1960s. C.W. Rietdijk published his formulation in 1966. Hilary Putnam followed with his own version in 1967, approaching the same conclusion from a slightly different direction. What both of them argued, rigorously, mathematically, within the framework of special relativity, is that if the relativity of simultaneity is taken seriously, if we genuinely accept that there is no preferred frame of reference, no master clock, no God's eye now that overrides the locally valid nows of all the observers moving through space-time, then there is a deep sense in which distant events that have not yet happened for us are already happening for someone else, already present in another observer's slice, already real in whatever sense real applies to an event in the block universe. Roger Penrose, one of the most careful and profound mathematical physicists of the 20th century, gave this argument its most vivid and widely shared form in his 1989 book, The Emperor's New Mind. And the version he chose, the image he reached for, to make the geometry feel concrete, is the one I find most quietly startling of all, even after thinking about it for a long time. Two people, a street, Andromeda, 2.5 million light-years away. The two people are passing each other on a pavement, not hurtling through space, not aboard rockets, just walking in opposite directions at the sort of pace you might use to get from one end of a high street to the other. A few kilometers per hour, let's say, which in terms of the speed of light, c, are fixed, invariant, universal constant at 299,792,558 meters per second, is a fantastically small fraction. 0.3 of a meter per second is a velocity to c ratio of about 1 part in a billion. 1 part in a billion. And yet, the now slice of the person walking toward Andromeda, tilted by that tiny, unhurried velocity in the direction of the galaxy, intersects events on Andromeda that are, by Andromeda's own local timeline, several days in its future relative to the other person's now slice. The person walking the other way, moving away from Andromeda at that same quiet pace, has a now slice that intersects Andromeda's past by several days. Penrose was quite specific about what this means for a particular imagined event. Somewhere in Andromeda, in the Andromeda galaxy, our nearest large galactic neighbor, a system of roughly 1 trillion stars 2.5 million light-years away. Suppose an alien civilization is debating whether to launch an invasion fleet toward our part of the universe. A council meeting. A decision yet to be made, or perhaps already made. For one of the two pedestrians on that ordinary pavement, the debate in Andromeda is still happening. The fleet has not yet launched. The decision has not yet been taken. It lies in what is, by their frame's honest reckoning, the future. For the other pedestrian standing one step away, the meeting is over. The decision was made. The fleet, in whatever form Penrose invites us to imagine it, has already departed. It lies in what is, by their frame's equally honest reckoning, the past. One step apart, opposite conclusions about what exists right now on the nearest large galaxy to our own. And both of them are right. There is no experiment you can perform, no measurement you can take, no signal you can send fast enough to determine which of them has the real now. Physics does not provide a tiebreaker. There is no master clock. The principle of relativity, the first postulate of Einstein's 1905 paper, denies any privileged observer. Every inertial observer's frame is as valid as every other's. The pedestrian walking toward Andromeda has a real, physically meaningful now slice that places the fleet's departure in its past. The pedestrian walking away has a real, physically meaningful now slice that places the fleet's departure in its future. Both of those slices are genuine hypersurfaces in Minkowski spacetime. Neither outranks the other. The loaf holds them both. The loaf does not care which slice you cut. Now I want to stay here for a moment. I'm not to add more numbers, but to let the shape of this settle, because I think there is something important in the specific texture of the Andromeda paradox that is easy to slide past in the rush to the next idea. The paradox does not require exotic speeds. It does not require anything remotely near the speed of light. It does not require particle accelerators or cosmic rays or twin astronauts aging at different rates. It requires only the banal, unremarkable motion of a person walking, and it requires distance, just distance. The distance is doing essentially all the work, amplifying the tiny tilt of the now slice, that Vxc2 term, from the Lorentz transformation, into something that spans days on a civilization millions of light-years away. And this is the thing that I find quietly unsettling in a way that the more familiar time dilation stories, the muons, the atomic clocks, the twins, do not quite produce in me. Those stories are about rates, clocks running at different speeds, elapsed time being different for different travelers, That is strange and real and experimentally confirmed, but there is something almost intuitive about it once you have sat with it long enough. Motion affects clocks, fine. But this, the relativity of simultaneity, is not about rates. It is about which events exist in your now at all. It is about the content of the present. It is about the question of what is happening right now somewhere else. And the answer is not we don't know yet because the light hasn't reached us. The answer is that there is no single fact of the matter. There is your now, valid in your frame, and their now, valid in their frame. And the geometry of space-time provides no adjudicator. That is the deeper strangeness. That is what Greene's loaf is trying to show you. The slice is real. Your slice is real. And other slices, cut at other angles by other observers, moving differently, are equally real. They are all present in the loaf. They all exist, and they disagree. There is one more consequence of all this that I want to bring to you before we move on. It follows directly from the Rietdijk-Putnam argument, and it is the thing that gives the block universe. The idea that past, present, and future are all equally real, all equally present in the fabric of space-time. Much of its philosophical weight, if for a distant observer moving in one direction, the events of your future are already present in their now, if those events are already as real and determinate as the events of your yesterday, then in what sense can we say the future is genuinely open? In what sense is it not yet real? If your death is already sitting in someone else's present moment, simultaneous with their Wednesday afternoon or their Tuesday morning, then where is the unreality in it? Where is the openness? This is the argument Rietdijk made in 1966. This is what Putnam formalized in 1967. And it is the argument that leads, carefully, philosophically, not recklessly, to the block universe, to eternalism, to the idea that the universe is not a river of becoming with only the present moment genuinely real and the future genuinely not yet existing. It is a block, a loaf, a four-dimensional structure in which every event at every time simply is. Einstein himself appears to have believed something like this, or at least to have moved toward it, in the years when his understanding of space-time had deepened beyond what any other living physicist had access to. In March of 1955, just weeks before his own death, he wrote a letter of condolence to the family of his lifelong friend Michele Besso, who had just died. And in that letter, private, personal, written by an old man who knew he was not far behind, he offered this: "People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion." A stubbornly persistent illusion. He did not say time is meaningless. He did not say nothing matters. He was trying to offer comfort, to say that Besso, in some physically real sense, was not gone because the space-time in which Besso existed was not gone. The events of Besso's life were still there, still real, still present in the four-dimensional fabric. The now had moved on. The slice had shifted, but the event itself, Besso's existence, his laughing and thinking and arguing about physics with Einstein over decades of friendship, that was as permanently woven into the structure of space-time as any event that had ever occurred. It is a remarkable thing to say, and Einstein said it knowing exactly what he meant. But, and here I want to be careful with you because the geometry deserves honesty as much as it deserves wonder. The block universe is an interpretation. It is a deeply motivated interpretation, one that follows naturally from the geometry of Minkowski's space-time and the relativity of simultaneity, one that Einstein and Minkowski and Putnam and many physicists and philosophers since have found compelling. but it is not itself a physical measurement. It is a philosophical conclusion drawn from physical facts. And there are philosophers and physicists who dispute it, who argue for what is called presentism, the view that only the present is genuinely real, that the future is not yet fixed, and the past has genuinely ceased to be. Some of them argue that there might be a true, privileged now that is simply inaccessible to us within the framework of special relativity. Some point to the cosmic microwave background rest frame, the particular frame of reference in which the afterglow of the Big Bang looks the same in all directions, in which the universe appears isotropic, as a natural candidate for a preferred cosmic time. We are, as it happens, not at rest in that frame. The Earth moves at roughly 370 kilometers per second relative to it, which is why we see a slight asymmetry in the CMB, slightly hotter in the direction we're moving toward, slightly cooler behind us. And in cosmology, that frame is genuinely useful. The FLRW metric, the mathematical description of an expanding, homogeneous universe developed by Alexander Friedman, Georges Lemaitre, Howard Robertson, and Arthur Walker, uses a cosmic time built on the CMB rest frame. It is in this cosmic time that we say the universe is 13.787 billion years old, the figure that comes from the Planck satellite's measurements published in 2018. That is a real, meaningful, scientifically grounded number, but it does not restore an absolute now in the sense that special relativity eliminates. Cosmic time is a convenient coordinate, a useful global reference built on the universe's large-scale symmetry. It does not override the locally valid simultaneity disagreements of any two observers moving differently through space-time. You and someone moving past you at a different velocity still disagree about which distant events are now, regardless of what cosmic time says. The CMB frame is helpful for cosmological calculations. It is not a master clock. It does not give you back the universal present that the Lorentz transformation took away. So the debate continues. Presentism and eternalism remain genuinely contested in the philosophy of physics. Smart people, careful people, people who understand the geometry, land on different sides. What physics can say for certain is this: there is no observational, experimental, empirically accessible evidence for a preferred frame. There is no measurement that singles out one observer's now as the real one. The principle of relativity holds, and within that principle, the relativity of simultaneity is not a loophole or an approximation. It is built into the structure of space-time at the deepest level we currently understand.
Now, there is something I have been holding back, and I want to give it to you properly because it matters enormously. It is the thing that keeps all of this, all of the now slice tilting, all of the Andromeda paradox, all of the block universe vertigo, from becoming something genuinely lawless or frightening. It is what separates the universe is strange from the universe is chaotic. And it is, I think, one of the most elegant and reassuring pieces of physics there is.
It is the light cone, and to understand it, we need to talk about how events in space-time are related to each other. Not all events are created equal in terms of their relationship to one another. This is one of the deepest and most consequential insights in all of special relativity, and it is encoded in something called the space-time interval, an invariant quantity, the same for all observers regardless of their motion, that classifies the relationship between any two events in space-time. The space-time interval between two events depends on both their separation in space and their separation in time. You can think of it loosely as a kind of four-dimensional distance, but with a crucial twist because time and space enter the calculation with opposite signs. And it is that asymmetry that gives rise to the three fundamental categories of event separation. The first category is time-like separation. Two events are time-like separated if the time between them is large enough relative to the spatial distance between them that a physical object, something moving at less than the speed of light, could travel from one to the other. If you are reading this and someone on the other side of the room drops a glass in 5 seconds, those two events, your reading now, the dropping then, are time-like separated. A signal, a person, a cause could connect them. And here is the crucial, beautiful fact. For time-like separated events, all observers, every single one, moving at any velocity less than light anywhere in the universe, agree on the order. If event A caused event B, if A came before B in the time-like chain, then everyone in every inertial frame agrees A came first. The order is invariant. It is baked into the geometry. It cannot be reversed. The second category is space-like separation. Two events are space-like separated if the spatial distance between them is so large and the time between them so small that even a signal traveling at the speed of light could not make it from one to the other in time. Nothing physical, no matter, no signal, no influence of any kind, can connect them. They are, in the precise technical sense, causally disconnected. And for space-like separated events, different observers in different frames of reference genuinely, validly disagree about which one came first, or whether they were simultaneous. There is no fact of the matter that all observers share. The order is not invariant, it is frame-dependent. And the third category is light-like or null separation. These are events that can be connected by a signal traveling at exactly EC at the speed of light itself. A photon leaving your eye and arriving at the wall, a flash of light emitted and received. For these events, the space-time interval is precisely zero. The geometry counts them, in a specific mathematical sense, as occupying the same distance in space-time, even though they may be physically far apart in space. The light cone, that structure you may have seen in diagrams of space-time, the two cones opening into the future and past from any given event, is the boundary between the time-like and the space-like. Everything inside the future cone can be influenced by you, the event at the apex. Everything inside the past cone could have influenced you. Everything outside both cones, in what is called the elsewhere region, the space-like zone, is beyond your reach. You cannot affect it. It cannot affect you. You are causally disconnected from it in both directions. And it is only the events in the elsewhere region, the space-like separated events, for which the relativity of simultaneity operates. It is only for those events, the ones that no cause and no signal can connect to you right now, that different observers disagree about which is earlier or later or simultaneous. The universe permits the disagreement precisely because nothing can be harmed by it. No information is transmitted, no cause is reversed, no effect is made to precede its cause. The light cone is the firewall. This is the single most important thing to hold on to in the whole story of simultaneity. The past cannot be changed, not because of any law against it, not because of any philosophical principle about the arrow of time, but because of geometry, because the events in your past and the events that actually influenced you, the causes that led to the effects you carry in your memory and your body, are time-like separated from you. And for time-like separated events, the order is invariant. All observers agree on it, forever, unconditionally. There is no frame of reference, no velocity, no now slice in the whole of Minkowski space-time that can flip the order of a cause and its effect. The only events whose simultaneity is negotiable are the ones that had absolutely nothing to do with each other, the ones that are genuinely physically incapable of sending any signal between themselves, of influencing each other in any way, because they are too far apart in space relative to the time available. For those events, and only those, the order is a matter of which frame you ask. So when we say that a distant being's now slice might intersect both your birth and your death at different moments in its own experience, we are saying something profound about the geometry of space-time and the nature of now. But we are not saying that the being could have done anything about either of those events, or that the order of your life is negotiable, or that cause and effect have become unreliable. Your life, the chain of causes and effects that constitutes it, unfolds in time-like sequence. Everyone agrees on that sequence. The being in the distant galaxy, however it tilts its now slice, cannot reach into your timeline and reorder it, cannot change which moment came before which, cannot make your childhood happen after your old age. What changes is only the labeling. The word now. The assignment of distant events to my present moment. That assignment is real and physical and not arbitrary. It is determined by the geometry of space-time and your particular motion through it. But it is local to you, it is your slice of the loaf. And changing the angle of your slice does not physically rearrange the loaf. This is the counterweight I promised you, and I want you to feel the weight of it properly. The universe is strange, the now you take for granted, the unexamined assumption that somewhere out there in the universe there is a single, shared present that you and a distant being and everyone in between all inhabit together. That assumption is wrong. Physics says so in the most mathematically precise and experimentally confirmed way available to us. The present is local, the present is your own. The present does not extend cleanly and unambiguously across the universe, carrying everyone along in step. But the laws of physics are not negotiable in the way that now is. Cause still precedes effect in every frame, for every observer, without exception. The world is not rewriting itself based on how different beings cut their slices. The events are all there in the loaf, fixed and real and unchangeable. What varies is only which cross-section you are standing on, which events you call simultaneous with me right now. The strangeness is in the labeling of now. The stability is in the time-like chain of causality. Both are real. Both are part of the same geometry. And they need each other, the one to make the universe genuinely strange, the other to keep it genuinely sane. There is something almost comforting in that if you let yourself settle into it. Not the falsely reassuring comfort of everything is fine, the universe makes perfect intuitive sense. The more durable comfort of understanding something true, of having the strangeness laid out honestly all the way to its edge, and then finding that the edge is a wall that holds. Causality is that wall. The light cone is the shape of it, and the wall does not give. So here we are. We have come a long way tonight, and I want to let you rest for a moment before we go further. You have been a generous companion through some very strange geometry. You have understood, at least in the way that matters for tonight, why the speed of light being constant for everyone, that stubborn, irreducible fact at the heart of Einstein's 1905 paper, forces observers in relative motion to disagree about which distant events are happening now. You have felt the arithmetic, a walking pace a few meters per second, amplified across 2.5 million light-years of distance, becomes a disagreement of days. 1 billion light-years becomes years. The universe is not subtle about this. The math is not approximate. It is exact and unforgiving, and it scales without limit. You have seen the loaf, Greene's loaf, that patient and capacious image from the fabric of the cosmos. You have understood that your now slice is real and locally valid and completely, irrevocably yours, but that it is not the only slice, not the correct slice, not the one that all observers share. The loaf holds them all. Every angle is valid. Every slice picks out a genuine hypersurface in Minkowski spacetime. You have sat with the Andromeda paradox, two pedestrians on a pavement, one step apart, disagreeing about whether an alien fleet has launched 2.5 million light-years away, and understood that this is not a thought experiment in the sense of something too impractical to take seriously. It is a thought experiment in the sense of something that reveals the actual geometry of spacetime, exactly as Penrose intended when he put it in The Emperor's New Mind in 1989, exactly as Rietdijk and Putnam intended when they formalized the argument in 1966 and 1967. And you have understood the light cone, the firewall, the reason that none of this strangeness dissolves into lawlessness. Time-like events keep their order forever in every frame. Space-like events, causally disconnected, unreachable by any signal, are the only ones whose simultaneity is negotiable. The past does not change, only the labeling does. That is quite a lot to carry. Let it settle if you need to. No rush. Because we are not finished yet, there are a few more things I want to give you before this night is done. The question of the experiments, the atomic clocks, the muons, the GPS satellites that quietly prove every day that time genuinely runs differently for different observers. The question of what it means to have an unambiguous now at all, and why the only honest answer is that your unambiguous now lives exactly where you are. The question of what scientists mean when they say the universe is 13.787 billion years old, and why that number is real and meaningful even in a universe with no universal now. The live, unresolved, genuinely contested debate between the eternalists and the presentists, the people who think the block universe is the truth and the people who think something more subtle is going on. And there is Einstein's letter, the one he wrote to Michele Besso's family in March of 1955, the one that may be the most quietly devastating sentence any physicist ever wrote about the nature of time. We will get there, we will take it slowly. For now, just rest here with the loaf and the light cone and the pedestrians on the pavement. Let Andromeda be whatever it is from where you are standing, 2.5 million years of light travel away, turning whatever light it is currently emitting, or rather, the light it emitted 2.5 million years ago, since that is all we will ever see of it from here, into that faint smear you can just barely make out on a clear night if you know exactly where to look. 2.5 million light years. And two people walking in opposite directions can disagree validly and irreducibly about what is happening there right now. The universe contains this. The universe has always contained this. It was there, quietly geometric and non-negotiable, long before Minkowski stood up in Cologne in 1908 and told a room full of mathematicians and physicists that space and time were doomed to fade into shadows. Long before Einstein wrote his 1905 paper in the Bern Patent Office. Long before there were any pedestrians or any pavements or any beings anywhere to notice that their now slices were tilted at different angles. The geometry was patient, it waited for us to find it. And now that you have on this particular night, in whatever room you are in, at whatever hour it is where you are, it seems worth asking the question that comes next. The question that the geometry, once you have fully felt it, almost forces you toward. If there is no universal now, if the present is not a shared cosmic clock signal that reaches every observer simultaneously and says, this moment, this one right here, then what does that mean for the reality of the future? If a distant being already holds your death in its now, already has it in its present moment slice of the loaf, then is the future real? Is it already fixed? Is it already there? This is where physics hands the question to philosophy. And philosophy, to its credit, does not pretend to have settled it. We will walk into that territory together, carefully, in the time we have left. But first, the experiments. The proof that this is not merely a conceptual game. The GPS satellites overhead, silently correcting for effects that Einstein would have recognized immediately. The muons streaming down through the atmosphere, lasting longer than they should by any non-relativistic calculation, their decay clocks running slow in exactly the way the theory demands. The atomic clocks that flew around the world in 1971 and came back disagreeing with the ones left on the ground by exactly the number of nanoseconds the equations predicted. The equations were right, they were always right, and the universe, strange as it is, has never once failed to confirm it. So let us begin there, with the proof. Because it would be easy, having spent all this time in the realm of thought experiments and geometry and the tilted planes of simultaneity, to let the mind grow comfortable with the suspicion that this is a kind of sophisticated poetry, a beautiful way of thinking about the universe that physicists have developed over the decades, elegant and internally consistent, but perhaps not fully anchored in the hard, stubborn, testable world of things you can weigh and measure and hold in your hand. It would be easy to think the train and the embankment, the loaf of bread, the alien fleet that has or hasn't launched, depending on which way you're walking. These are pictures, useful for building intuition, but not quite the same as truth. And so the universe, being the universe, decided to prove it. It proved it first with particles, tiny, unstable particles called muons, created high in the Earth's atmosphere when cosmic rays, high-energy protons and other particles streaming in from space collide with atoms in the upper air. Muons are not friendly to long journeys. They are inherently unstable. Left to their own devices, a muon will decay into other particles in about 2 microseconds, 2 millionths of a second. That is not very long. And the upper atmosphere, where they are born, is roughly 15 kilometers above your head. Even traveling at very nearly the speed of light, a muon should only cover about 600 meters in 2 microseconds before it ceases to exist. It should not come anywhere close to the ground. There should be almost no muons at the Earth's surface. This is what the non-relativistic calculation tells you clearly and firmly, and yet the ground is full of them. Muons rain down on the Earth's surface in enormous numbers, thousands of them passing through your body every minute, all of them having made the full 15-kilometer journey that physics said they couldn't survive. This was measured. In 1941, the physicists Bruno Rossi and David Hall set up a careful experiment to count muons at different altitudes, and the numbers confirmed what the strange new theory had been quietly insisting. The muons were surviving the journey because, from the muons' perspective, the journey was much shorter than 15 kilometers. From the ground's perspective, the muons' internal decay clock was running slow. It was ticking at a fraction of its usual rate because it was moving so fast, so close to the speed of light, that time itself was stretched out for it. What felt like 2 microseconds to the muon was far longer from where we were standing, long enough to cross the atmosphere, long enough to reach the ground. Time dilation. The moving clock runs slow, not because the clock is broken, not because of vibration or heat or any ordinary physical effect, because time itself is doing something different for an observer in motion compared to one at rest. The Rossi-Hall experiment didn't just confirm a theory, it measured a phenomenon that had no explanation at all outside of relativity. There was no other framework that made the muons make sense. You could not explain the Rossi-Hall numbers without the relativistic time dilation, without the idea that motion and the passage of time are bound together in a way that Newton never imagined. Now, it is worth pausing here for a moment because this is the place where two things that feel similar can get quietly mixed together, and keeping them distinct is actually important. Time dilation and the relativity of simultaneity are close cousins in the same family, but they are not the same thing, and understanding the difference is one of those small satisfactions that makes the whole picture click into focus. Time dilation is about clock rates. It is about how fast a clock ticks. A clock in motion or a clock deep in a gravitational field ticks more slowly than one that is stationary and in weaker gravity. This is a difference in the pace of time, how many seconds accumulate per second, so to speak. It is real, it is measurable, and the muons falling through the atmosphere are its living proof. The relativity of simultaneity is about something different. It is about clock offsets. It is about which events count as happening at the same moment. It is not about the rate at which time flows for a given observer, but about the geometry of which events that observer includes in their now slice. The particular angled cut through the loaf that defines for them the present moment. When we say that two people on a sidewalk disagree about what is happening right now in the Andromeda galaxy, we are not saying their personal clocks are ticking at different rates. We are saying their now slices are tilted differently. They are, at that moment, cutting the bread at slightly different angles, and the cut lands on a different Wednesday in Andromeda for one than it does for the other. Both effects are real, both come from the same deep structure of space-time, but they are not the same effect, and it matters to hold them apart, because confusing them leads you to think you understand something when you have actually blurred two distinct phenomena together. The rate at which your clock ticks and which distant events you call now are separate consequences of the same geometry. They feel similar because they both involve time behaving unexpectedly, but the muons in the atmosphere are a demonstration of the first, not the second. The sidewalk strangers disagreeing about Andromeda are a demonstration of the second, not the first. Keep them in separate drawers in your mind and you will find the whole theory considerably less confusing. Good. Now back to the proof. 20 years after Rossi and Hall measured the muons in 1971, two physicists named Joseph Haffel and Richard Keating did something that sounds almost charmingly low-tech for a fundamental test of one of the 20th century's great scientific theories. They took 4 cesium atomic clocks, extremely precise, the most accurate timekeepers available to them, and they put the clocks on commercial passenger jets and flew them around the world, twice, once eastward and once westward. And then they compared the times on the traveling clocks with the times on identical clocks that had stayed on the ground throughout. The cesium clocks, as atomic clocks do, kept time to extraordinary precision, and when the flying clocks came home, they disagreed with the ground clocks, not by a lot. We are talking about nanoseconds, billionths of a second, but they disagreed by exactly the amount the equations of special and general relativity predicted they would. The eastward trip and the westward trip produced slightly different amounts of disagreement because the jets' velocities relative to the Earth's rotating surface were different in each direction, and the gravitational effect also played a role, and all of this was accounted for by the theory to a degree that would have been astonishing if the theory hadn't already been trusted for more than 6 decades at that point. The clocks that flew came back having aged slightly differently than the clocks that stayed, not by much, but by exactly the right amount. There is something quietly moving about that experiment. Haffel and Keating booking seats on commercial airliners with atomic clocks beside them, writing up their results for the journal Science in 1972, confirming that the equations Einstein had worked out in a patent office in Bern before the First World War were correct to nanosecond precision. The universe didn't have to cooperate. It could have refused. The clocks could have come back showing identical times, and the whole framework would have needed to be reconsidered. But they didn't. The clocks disagreed. The universe cooperated, as it always has, with the mathematics, and then there is GPS. If you have ever navigated to a new address, found a restaurant in an unfamiliar city, or watched a map on a screen tell you that you need to turn left in 300 meters, you have used a system that would not work at all without the corrections that Einstein's relativity demands. The global positioning system consists of a constellation of satellites orbiting the Earth at an altitude of roughly 20,000 kilometers. Each satellite carries an atomic clock. The system works by comparing the timestamps from multiple satellites and using the tiny differences in arrival time to calculate your position on the ground with extraordinary accuracy. But here is the problem. The satellite clocks and the ground clocks run at different rates, for two separate reasons, both relativistic. The first reason is special relativistic. The satellites are moving at orbital speed, roughly 14,000 kilometers per hour relative to you. Because they are moving faster than the ground clocks, their clocks tick more slowly. This is time dilation. The satellites' clocks, for this reason alone, fall behind ground clocks by about 7 microseconds per day, 7 millionths of a second every day. The second reason is general relativistic. The satellites are higher up, farther from the center of the Earth, in a weaker gravitational field. And time passes faster in weaker gravity than in stronger gravity. Clocks run fast in the low-gravity environment of orbit compared to the high-gravity environment at the Earth's surface. This is gravitational time dilation, an effect that Einstein's general relativity predicts and that is also measurable with sufficient precision. This effect makes the satellite clocks run fast by about 45 microseconds per day relative to the ground. Combine both effects, minus 7 microseconds from the speed, plus 45 microseconds from the altitude. The net result is that GPS satellite clocks tick about 38 microseconds faster per day than the ground-based clocks they need to stay synchronized with. 38 microseconds, that sounds small. And in the context of an ordinary day, it is. But the GPS system works by measuring light travel time between satellites and your receiver, and light travels about 30 centimeters in 1 nanosecond. 38 microseconds is 38,000 nanoseconds, 38,000 times 30 centimeters. That is roughly 11 kilometers of positional error accumulating every single day if you do not correct for it. The physicist Neil Ashby worked through this in detail, and the numbers have been verified continuously since GPS became operational. Every day, the satellite clocks are adjusted, or rather, the clocks are set slightly slow before launch, precisely to account for the fact that they will run fast once they reach orbit. The correction is built into the system. Without it, your GPS would drift by about 10 kilometers per day and would be essentially useless for navigation within a week. This is not a small engineering footnote. This is relativity as a piece of indispensable infrastructure. The precision of modern positioning technology rests entirely on the fact that time runs at genuinely different rates in different gravitational fields and at different velocities, and that the engineers who designed GPS knew this and corrected for it. Every time your phone finds you on a map, it is confirming, in the most practical way imaginable, that Einstein was right. The satellites know where you are because the people who built them trusted the equations. The equations that began in 1905 with a thought experiment about a train and a man watching lightning from an embankment. So no, this is not philosophy dressed as science. This is science that has been weighed, timed, measured, and engineered into the device sitting on your nightstand. The strange behavior of time is not a thought experiment anymore. It is a GPS satellite. It is a muon. It is a cesium clock that came home from a trip around the world with the wrong time on its face. And here is the quiet, slightly vertiginous conclusion that all of this experimentation delivers. There is no preferred frame, no master clock, no observer in the universe who gets to be right in a way that overrides everyone else, no God's eye view from which the single, universal, absolute now can be read off. Every inertial observer's now is as valid as every other's. Physics provides no way to single out a universal present. The first postulate of special relativity, the principle of relativity, says that the laws of physics look the same for every observer in uniform motion. Nobody is more right than anybody else. Nobody gets to claim that their particular slice through the loaf is the real one, and everyone else's is approximate. Your now, the unambiguous, unarguable, genuine present moment, exists only here, only at your own location, only at the events that are happening right where you are, right when you are. The further away an event is in space, the more uncertain, the more convention-dependent, the more frame-relative the question of whether it is happening now becomes. You can define now for distant events. You can set up clocks and synchronize them and assign timestamps and talk about simultaneity in a perfectly consistent and useful way. But the assignment depends on your motion. Change your motion, and a different set of distant events falls into your now. This is what Einstein called the synchronization convention, or the Einstein synchronization, and it is exactly that, a convention, a choice. A cut through the loaf made at an angle that depends on how fast and in what direction you are moving. There is nothing wrong with the convention, it works beautifully, but it is not a discovery of a universal present. It is a choice of which slice to call present made locally and valid locally. Your now is yours, and only yours. Now, around this point in the conversation, a certain very reasonable objection tends to arise, and it is worth taking it seriously because it sounds, on first hearing, like a decisive counter-argument. Scientists say, and they say it with great confidence and with the backing of extraordinary amounts of data, that the universe is 13.787 billion years old. 13.787 billion years with an uncertainty of plus or minus 20 million years. That is a very precise statement about the age of the universe. It implies that the age of the universe is a meaningful concept. And if the universe has an age, if there is a number of years that correctly describes how long it has existed, then isn't that a universal now? Isn't the age of the universe a kind of cosmic clock ticking away for everyone equally, giving us the universal present that relativity supposedly denied us? This is a good question. It deserves a real answer. The age of the universe is defined using what cosmologists call cosmic time. Cosmic time is the time measured by a special class of observers who are, in a particular technical sense, at rest with respect to the large-scale structure of the universe itself. The universe on the very largest scales looks remarkably smooth and uniform. Matter is distributed roughly evenly across enormous volumes.
And the universe is expanding, every galaxy cluster slowly moving away from every other galaxy cluster, the space between them stretching. In this expanding, roughly smooth universe, there is a natural family of observers. The ones who see the universe as expanding uniformly around them in all directions, who are not moving in any particular direction relative to the overall cosmic flow, who are, in effect,
carried along with the expansion like dots painted on the surface of a slowly inflating balloon. These observers see the cosmic microwave background, the faint afterglow of the hot, early universe, the oldest light we can detect, as equally bright and equally warm in every direction. The Earth, as it happens, moves at about 370 kilometers per second relative to this special frame, which is why the cosmic microwave background looks very slightly brighter in the direction we're moving toward and very slightly dimmer behind us. This is a measured effect, but the frame in which the CMB looks perfectly isotropic, equally bright in all directions, is the frame cosmologists use to define cosmic time. The FLRW metric, named for Alexander Friedman, Georges Lemaitre, Howard Robertson, and Arthur Walker, describes an expanding universe using this special time coordinate. The Planck 2018 results from the exquisitely sensitive measurements of the Planck satellite fix the age of the universe in this framework at 13.787 billion years, plus or minus 20 million. So cosmic time is real, it is useful, it is based on a genuine physical feature of the universe, its large-scale homogeneity, and the CMB, and it gives us a meaningful, consistent, beautifully well-determined answer to the question of how old the universe is but it does not restore the absolute now that relativity took away. Here is why. Cosmic time is a convenient global coordinate. It uses the special class of CMB rest observers as its reference, because those observers happen to live in a universe that looks symmetric to them, and so they make a natural choice for defining a shared time. But this is a convention, a very natural and useful one, but a convention nonetheless. Observers who are not in the CMB rest frame, observers who are moving relative to it, which includes you and everything around you, do not experience cosmic time as their local time. And more fundamentally, the existence of cosmic time as a useful label does not mean that two spatially separated events that are simultaneous in the cosmic time coordinate are, in any absolute, physics demands its sense, happening at the same moment. The simultaneity built into the FLRW coordinate is still a coordinate choice. It works because the universe, on large scales, happens to be simple enough to support it gracefully, but it is still a slice through the loaf. A very natural and very well-motivated slice, but a slice. Think of it this way. If you are in the middle of a field and you want to draw a line pointing north, you can do that. There is a natural direction toward the geographic North Pole, and it makes a reasonable reference, but north is still a convention. Someone who defines forward as the direction they happen to be facing will point somewhere different. Cosmic time is like north, a natural reference built on a genuine physical feature of the universe, but not a discovery of some frame-independent absolute. It does not tell you that two distant events are objectively, universally, absolutely simultaneous. It tells you they are simultaneous in the coordinate system cosmologists find most convenient for describing the universe's large-scale evolution, and that is genuinely useful. And it is also genuinely not the same thing as an absolute now. The universe is approximately 13.8 billion years old. That is a true and meaningful statement, carefully earned by science. And there is still no universal present moment shared by all observers everywhere. Both of these things are true at once. They do not contradict each other. Cosmic time is a gift the universe gave us because it happens to be smooth on large scales. It is not a rescue of absolute simultaneity. It is a very beautiful coordinate. And so we arrive, finally, at the question that has been waiting patiently at the edge of everything we've discussed. The question the geometry almost demands once you have sat with it long enough. If there is no universal now, if the present is genuinely local, genuinely observer-dependent, if a distant being can have a now slice that holds your birth in one moment and your death in the next, then what does that mean for the reality of the future? Is the future already there, already existing, already fixed, already waiting in the four-dimensional loaf for the slow procession of your experience to arrive at it? This is where physics hands the conversation to philosophy, and philosophy, honestly and admirably, has not finished the conversation. The view that falls most naturally out of the mathematics is called eternalism, or the block universe. If there is no objective moving present that single out one moment of time as the now, then there is no special status for the present over the past or the future. All moments, all events at all times simply exist. The loaf is the loaf. The four-dimensional space-time block contains every event that has ever happened or ever will happen. The past is not gone. It still exists in its region of the block. The future is not uncertain. It exists in its region. The apparent flow of time, the sense that moments succeed one another, that the present is uniquely, vividly real, is a feature of the experiencing mind, not a feature of physics. What we call the flow of time in this picture is perhaps something like the way a movie camera moves along a strip of film. It is not the strip of film itself moving, it is a perspective moving through something that is, in its entirety, already there. This is the view associated with Hermann Minkowski's geometry formalized in 1908 when he gave his famous address in Cologne, and declared that space and time separately were doomed to fade into mere shadows. It is the view defended by the philosopher Hilary Putnam in his 1967 paper, Time and Physical Geometry. It is the view that C.W. Rietdijk was driving at in his 1966 paper, which the Andromeda paradox is sometimes called the Rietdijk-Putnam argument for. It is the view that Greene describes with such care and elegance in The Fabric of the Cosmos, where the loaf-of-bread image lives. It is, in some form, the view that many physicists adopt, not necessarily because they have proved it, but because the mathematics of spacetime seems to lean in that direction, and because it is difficult to articulate what a moving now would even mean in a geometric framework where all moments exist as coordinates in a four-dimensional manifold. The opposing view is called presentism. Presentists argue that only the present is real, i.e. that the past genuinely no longer exists and the future genuinely does not yet exist, and that the present moment is the one actual, real time, the one that matters in a way that no other does. This is in fact much closer to how most people experience time. The past feels gone, the future feels open, the present feels vivid and real in a way that memory and anticipation do not. Presentism is, you might say, the common-sense view dressed up in philosophical language. The problem is that presentism has difficulty making peace with relativity. If only the present is real, and if different observers have different presents, if what you call now and what a fast-moving observer calls now genuinely disagree about which distant events are included, then either one of you is wrong, which the physics doesn't support. Both nows are valid. Or different observers disagree about which things exist, which leads to very uncomfortable conclusions. Or there is a preferred frame that secretly determines the real present, even though physics can't tell us which one it is, which is the neo-Lorentzian view, and which requires positing something undetectable, which most physicists find unsatisfying. None of these options is particularly comfortable. Presentism and special relativity sit together uneasily. They can be made to coexist with sufficient philosophical ingenuity, but the accommodation always has the feeling of two pieces of furniture that don't quite fit the same room. There is also the question of what the block universe means for free will and for the future being fixed. This is where interpretations tend to run ahead of the physics, and it is worth being careful. If the future already exists in the four-dimensional block, if the event of your death is already there, already a real feature of the space-time manifold, then in what sense is your future open? In what sense do your choices matter? Here is what is honestly true. The block universe, as a description of space-time's geometry, is not the same thing as fatalism. The events in the block, including the events of your future, may be fully determined. But the same question of determination, of cause and effect, exists whether you think of the block as static or not. Physics describes what happens given initial conditions and the laws of nature. Whether you call the resulting history a block or a becoming, the relationship between cause and effect is the same. Your choices are, within the block, real events with real causal consequences. They are in the block too. The choice you make influences which future events follow, just as the same causal laws would dictate in any other framework. What the block universe does not give you is the sense that the future is genuinely open in the sense of being indeterminate. But then again, classical physics never gave you that either. Quantum mechanics muddies these waters considerably in ways that are genuinely unresolved, and the relationship between quantum indeterminacy and the block universe is itself an active area of debate that we will not try to settle tonight. It would not be honest to settle it. Nobody has. What the block universe gives you in exchange for the open future is a kind of permanence. The past does not disappear. Your younger self is still there, in its region of the block, as real as anything. Every moment you have lived still exists. The lunch you ate on a Tuesday years ago, a phone call that mattered, the last time you saw someone you loved. All of it is still there, in the geometry, in the way that a note is still there in a song, even after the melody has moved past it. Whether that is comforting or unsettling probably depends on the mood of the night, and this is where Einstein appears one more time, not in a paper, not in a thought experiment, in a letter written on the 21st of March, 1955. He was writing to the family of his lifelong friend Michele Besso, who had just died. Besso and Einstein had known each other for decades. They had walked and talked together in Bern in the early years of the century when Einstein was working at the patent office and the theory of special relativity was forming in his mind. Besso, who was not himself a physicist of Einstein's stature, was nonetheless one of the people Einstein most loved to think alongside. And now, Besso was gone, and Einstein, who had only weeks left of his own life, he died the following month, on April the 18th, 1955, wrote to the Besso family to offer his condolence. And in that letter, he wrote this: "People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion." A stubbornly persistent illusion. Sit with that for a moment. Here is a man who has spent 50 years thinking more carefully about the structure of time than almost any human being who has ever lived, who built the framework within which the block universe is the natural conclusion, who understood from the inside what the equations meant. And in the last weeks of his life, writing in grief for a friend, he does not retreat from the implications of his own work. He leans into them. The distinction between past, present, and future, the thing that every waking moment of human experience insists is the most fundamental fact there is in his view, a stubbornly persistent illusion. He is not saying that time is not real. He is not saying that loss is not real, or that Besso's life did not matter. He is saying something more careful and more strange. That the particular way we carve up time, this is past, this is now, this is yet to come, does not correspond to a feature of the universe's deep structure. That the universe at the level of space-time geometry does not recognize a now that is universally present for all observers. That what feels like the present moment is a local experience, vivid and real to the one having it, but not stamped across the cosmos as the one true time. 'Tis an extraordinary letter, written in grief, reaching for the only comfort available to a person who trusts the physics. Not that Besso still lives in any ordinary sense, but that his existence, every moment of it, is still real in the structure of space-time, in the block, in the loaf, in the geometry that does not erase the past, but merely moves our experience past it. Whether that is a comfort or not is a question that physics cannot answer for you. It is one the night will have to answer in its own way. And now we have travelled quite a long way together. Further than we might have expected when the night began, when you settled in, and the lamp was still on and the room was quiet. We started on a sidewalk, two strangers passing, one step apart, and a galaxy 2.5 million light-years away where, for one of them, an alien fleet had not yet set off, and for the other, the decision to launch had already been made. We started with something that felt like a puzzle, a neat little paradox, perhaps a bit of intellectual showing off by the universe. And we pulled at it, slowly, the way you pull at a loose thread. And what we found was the thread was load-bearing. It was holding up everything. The invariant speed of light, 392,000 miles per second, the same for every observer, always, without exception, forces observers in relative motion to disagree about which distant events are simultaneous. That is not a choice, that is not a convention, that is the mathematical iron consequence of C being what it is. The Lorentz transformation tells you exactly how much. The distance multiplies a tiny velocity into enormous time offsets, so that the slow walk of a person on a sidewalk, amplified by 2.5 million light-years, produces a disagreement of days about the state of a distant world. Minkowski understood that this meant space and time were not separate things but a single four-dimensional fabric, and that observers in relative motion were simply oriented differently within it, cutting the fabric at different angles. Each cut is valid. None is the real one. The angle of your cut, your plane of simultaneity, your now slice, is determined by your motion, and nothing else. This is what physics tells us about now. It is local, it is yours, and out there, across the distances that light takes millions and billions of years to cross, the geometry of space-time does not recognize it as binding. The experiments came and confirmed it. The muons that shouldn't have survived the journey from the upper atmosphere to the ground, and survived it anyway, their decay clocks running slow in exactly the relativistic way, Rossi and Hall measured them in 1941, and the numbers matched. The cesium atomic clocks that flew around the world on commercial jets in 1971, Eiffel and Keating brought them home, and they disagreed with the ground clocks by nanoseconds that the equations had predicted in advance. The GPS satellites overhead corrected every day for approximately 38 microseconds of relativistic drift. Neil Ashby worked through the mathematics, and the engineers built the correction in, because without it, the system would be 11 kilometers off by tomorrow morning and useless within a week. The universe has not once, in all of this measurement, offered the slightest whisper of a discrepancy. It cooperates with the mathematics, with a patience that, if you think about it long enough, begins to feel like something very much like grace. There is no preferred frame, no master clock, no God's eye now. Your unambiguous present exists only at your own location. Everything else is a choice of slice, tilted by your motion, valid for you, not imposed on anyone else. The universe is 13.787 billion years old, and that is a true and wonderful thing, a cosmic time defined by the large-scale geometry of the expanding universe, by the observers at rest with respect to the cosmic microwave background, by the FLRW metric and the Planck satellite's exquisite measurements. And even that, as real and as useful as it is a coordinate. A very natural slice through the loaf cut at the angle that the universe's own large-scale structure suggests. Not a restoration of absolute simultaneity, not a master clock, just the most convenient and most physically motivated way to tell the universe's story from the inside. And the block universe waits at the end of all of this, perhaps the most unsettling and perhaps the most strangely comforting idea that the geometry delivers, that the past is not gone, the future is not absent, that all of it, every moment that has ever happened to you, every moment that is still ahead, exists in the four-dimensional loaf with equal reality, and what we call the present is the place where our experience currently touches the structure, the way a finger traces a line through a map of a country that exists all at once, the whole of it there, whether the finger has reached it yet or not. This is not a proven fact, it is an interpretation, a very natural interpretation of very solid mathematics, contested by serious philosophers and physicists who argue for presentism, who argue that only now is real, who find ways to make that view coexist with relativity, uncomfortably, but honestly. The debate is live. The physics does not by itself settle it. Anyone who tells you it does is going slightly beyond what the equations actually say. What Einstein said in the last weeks of his life is what the geometry suggests, that the distinction between past, present, and future is a stubbornly persistent illusion, that it persists because we are creatures of time, experiencing it from the inside, one moment at a time, our consciousness moving through the block the way the lamp moves through the dark. And that illusion does not mean unreal. Your present moment is real. It is vivid, and it is yours, and it is the only place in the universe where your experience is actually happening. The illusion is not that the present exists. The illusion is that it is universal. The illusion is that there is a great clock somewhere, one the universe has agreed to run by, and that every star and every galaxy and every distant traveler is synchronized to the same tick. There isn't. There is only the local now, and the light traveling outward from it at 392,000 miles per second, carrying no news that will reach anywhere quickly enough to matter. And the geometry, silent and patient and indifferent to our preferences, doing what it always does. And here, on this particular night, in whatever room you are in, wherever you are listening from, whatever hour it is in your part of the world, all of this has been happening around you and inside you without your needing to know it. The clocks in your body are running at a rate slightly different from the clocks of someone in orbit. The now that you inhabit is genuinely, physically, irreducibly yours. The distant galaxies hold their own presence, their own slices of the loaf, angled by their own motions, carrying their own versions of which events on Earth count as simultaneous with right now. And none of this makes the world less real. It makes it more real somehow, more strange and more solid at once, the way the precise details of a thing always make it more there than the vague idea of it. You are right now a point in space-time, a location and a moment, singular and specific. Your now slice extends outward from where you are and cuts the universe at the angle determined by your current velocity, which relative to the cosmic microwave background is about 370 kilometers per second, Earth's motion through the cosmos, a motion that is itself determining right now which events on distant worlds fall into the thing you would call your present. You are not aware of this, you didn't choose it, you can't change it without moving, but it is happening as genuinely and as continuously as your heart is beating and the photons from the lamp beside you are traveling at sea in every direction, hitting the walls of the room and arriving at your eyes in the thin slice of the electromagnetic spectrum that your particular kind of eyes have learned to call light. The universe is not waiting for you to understand it, to keep being what it is. It has been doing all of this. The invariant speed of light, the tilted now slices, the distant galaxies with their own presence. Since long before there were minds to notice, since before the Earth existed, before the sun had formed, in the early universe when the first stars were kindling themselves in the dark out of hydrogen and the faint signatures of quantum fluctuations from a time so early and so strange that we only have the mathematics to describe it, and even the mathematics reaches a point and stops. The geometry was there. The structure of space-time was there. The absence of a universal now was built in from the very first moments. We came along later. We looked up. We noticed the strangeness. And through a series of steps that took, in total, only a few hundred years of careful science, from Newton's mechanics, through Maxwell's electromagnetism, through the crisis over the speed of light, and the young Einstein working quietly in a patent office and thinking about what it would be like to ride alongside a beam of light, we found it. We looked at the structure of the universe and we found that the one thing our intuition most insisted was simple and shared and absolute. The present moment, the now, was of all things the one thing the universe had quietly declined to share. That seems like it should be terrifying. The word in the title is terrifying, and perhaps on first contact it is. Perhaps there is a moment somewhere in this long, slow journey we have taken together where something shifts, where the orderly world in which everyone shares a now, in which simultaneous means what it sounds like it means, in which your sense of the present moment is a real feature of the universe rather than a local experience, gives way, and you are left looking at something stranger and larger and less accommodating than the world you thought you were living in. But then, if you sit with it long enough, something else tends to happen. The strangeness stops being frightening and starts being something more like wonder, because the universe doesn't need to have been this way. It could have been a simpler place with a universal time and a shared present and a master clock that everyone agreed to. It chose, or was built, or began, or simply is something far stranger and far more beautiful. A place where every observer carries their own now like a lantern, casting its light locally, not reaching far. A place where the geometry of four-dimensional space-time holds all moments equally real, and what moves is not time itself, but the experience of time, the awareness moving through the block the way attention moves through a remembered life. Not erasing what came before, not conjuring what comes after, just touching, one moment at a time, the thing that is already there. You are of that. The same geometry that governs the distant galaxies governs the neurons in your mind as they process these words. The invariance of C that forces the tilting of now slices is the same constant that determines how the stars shine and how the atoms in your body hold together. You are not separate from the physics. You are an instance of it, experiencing it from the inside in the only way it can be experienced, locally, personally, from a specific point in space-time with a specific velocity at a specific moment that is genuinely, irrevocably yours. And that is not a small thing, that is, if anything, a remarkable thing. Back at the beginning of tonight, I invited you to picture two strangers on a sidewalk, one step apart, disagreeing by days about the state of a galaxy 2.5 million light-years away. I asked where you were listening from, and I meant it. Because you, wherever you are, whatever city or town or field or room, whatever country, whatever hour of the night, you are one of those observers. You carry a now slice. It extends outward from where you sit, cut at the angle of your current motion, reaching out across the universe and landing on some particular set of events in some particular set of distant galaxies that count for you right now as simultaneous with this moment, and nobody else, not a single other observer in the universe moving at a different velocity, has exactly the same slice. Your now is singular. It has never happened before, and it will not happen again. If you have enjoyed this slow wander through space-time, if something along the way caught your attention and made the night feel a little stranger and perhaps a little larger, a gentle like, and a subscribe to this sleepy little channel would be very much appreciated. Small creators like Grandpa's Late Nights really do rely on your support to keep these journeys going, and drop a comment if you have the energy before sleep takes you. Where are you listening from tonight, and what time is it in your corner of the world? I read every one, and it is, I will confess, one of the things I most look forward to. Until next time. Good night, kiddo. Grandpa'll leave the porch light on. Eve.